What's going on, ladies and gentlemen? Welcome to episode 184 of the Junkies Podcast. Today I'm sitting down and chatting with Tony Sanchez, owner and operator at A&amp Welding in Salt Lake City, Utah. Tony was referred to me by Bill Komlos, who was on episode 160. They worked together on the Mars Perseverance project. Tony specializes in critical welds for the Department of Defense and the aerospace industry, and his favorite alloy to work with is aluminum, and he dropped some great information in this episode. But before we get into it, a quick word from the supporters of the show. Today's episode is brought to you by the Stepped Wedge. The Stepped Wedge is the most unique and innovative gapping wedge available for pipe fitters and welders. Head on over to gapandtack.com to see these bad boys in action. The Stepped Wedge comes in 3 different sizes. The pipeliner measures 1 3/4 by 8 inches. The standard is 1 1/4 by 6 inches. And the small or stubby version is 3/4 by 4 inches. Each wedge is available in metric or imperial. Imperial steps are incremental from 1/16, 3/32, 5/32, 3/16, and 1/4 inch. They even carry a spatter-proof version as well that has a smooth taper throughout the length of the tool. Each wedge features a hole at the top so you can add a lanyard so you can keep the wedge close by and handy at all times so you can set up your next gap. Pick up your wedge today at gapandtack.com and save a few bucks when you buy the full set. That's gapandtack.com. We're also brought to you by Fronius USA. And right now, they're running their Dip into Summer promo where you can get an instant $600 rebate when you buy a Magic Wave 230i in either air-cooled or water-cooled along with a Bluetooth accessory. You can choose from the Visor Connect welding helmet or a wireless foot pedal. The Fronius Magic Wave 230i AC/DC TIG machine is another huge step forward for the welding industry. Fronius brings together their state-of-the-art welding technology to a brand new AC/DC TIG machine. Every time Fronius comes out with a new machine, a new standard is set and the world of welding takes a huge technological leap forward. This machine is no exception to that. The Dip into Summer sales promotion is only available now through September 30th, so you still have time to take advantage of this awesome deal. We're also brought to you by Rockmount Research and Alloys, and now you can get all the great Rockmount electrodes, wires, and consumables you've come to know and love right through MSC Industries. Just go to mscdirect.com and check out their full listing of Rockmount products. And you can order directly through the website. And the best part is, they're offering free shipping on all orders. Rockmount rods and wires are designed to weld stronger and last longer than other electrodes. Stop putting band-aids on your repairs and get the job done right the first time, every time with Rockmount. And now with their partnership with MSC, it's even easier to get their products in your shop or home with MSC Direct. Rockmount has a rod and wire for every application and maintenance that you can think of. Whether it's dissimilar metals, bolt extractions, wear plates, hard facing, gouging, or cutting, they've got you covered. Rockmount rods are engineered to give you the best possible outcomes in the worst case scenarios. Because let's face it, that's the reality of our working environments. Maintenance and repair welds aren't meant to be done in the same facilities as initial fabrication. That's where Rockmount shines. So check out their full catalog today and get free shipping when you purchase through mscdirect.com. We're also brought to you by Everlast Welders. I just finished up a custom piece of workout equipment for a new client who's a personal trainer. I welded the entire frame up with my Cyclone 200E MIG welder and then welded in some capture nuts for some bolts to make a friction stop with my 255 EXT. Tell you what, having these 2 machines in my shop has been a great addition. They're both super simple to operate and they run great. I can't recommend these machines enough for the home hobbyist and small business owner. They're priced just right and handle everything I've been able to throw at them. Whether it's thin gauge stainless, miscellaneous aluminum projects, or production style MIG welding, you can get it all done with these machines. Head on over to everlastwelders.com today and find out which machine is right for you. They have a machine for every budget and skill level. And if you buy any machine that comes with a stock foot pedal, use code word ARCJunkies in the comment section at checkout and you'll get that free Nova foot pedal and TIG torch upgrade absolutely free. Alright, you know what time it is. Fire up your machines, drop your hood, and turn me up 5.
You're listening to the ARC Junkies Podcast. Helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, Tony, welcome to the show. I've had several of the previous guests talk about you, Magic Tony, as they refer you to. Bill Komlos was one of them. Chandler Vincent was another. They're like, man, you got to get Tony on the show. You got to talk to Tony. He's just a really incredibly well-versed welder. I seen the list of stuff that you sent over to me about some of the projects that you've worked on. So I appreciate you taking the time coming on the show, and I'm sure we're going to help out a lot of listeners tonight.
Well, thanks for having me on.
Oh, no problem. So what was it that, when did you get into welding?
Well, my dad worked at the college. It was College of Eastern Utah. That's about 2 hours south of here. And me and two of my friends signed up for college. And while we were there at the counter, my dad says, "What are you taking?" I said, "I don't know, Dad." And he looked at my friends and seen what they were taking. They were taking a welding class. He looked at me and says, "Take a welding class. We need it around the farm." Look what happened, It's, but those two, one made a career in railroad. The other one made a career as a welding teacher. Another person that you should talk to that taught Mason Winters. That's one of Chandler's teachers.
Okay.
But Jeff has been teaching kids for 40 years, and he's sent some good guys out. And I don't know how you guys can teach. I can bend metal, but man, people, good luck.
Yeah, it's an art form in and of itself.
Correct.
Yeah, I kind of use a lot of my personal experience as a welder, and I think out of all the things teaching welding has taught me is patience. Patience is a big one, because you get a lot of students in there. You get some of them that are stubborn. Some of them just, they're just not getting it. And that's what I like, is the challenge of trying to figure out a way. How can I reach this student? What way can I teach this to them to where they're going to grasp the concept? So I'll start asking them, like, what kind of hobbies are you into? What do you do outside of school? What are you into? Like, what do you like to read? What do you like to do? And, I'm pretty well versed in a lot of pop culture and different things like that. And, I'll just use different analogies and metaphors for, different welding processes until it clicks. Like I always, when I'm teaching 3G, anything vertical, I talk, I get a lot of kids that are, they're from Osceola, so it's like kind of backwoods a little bit, a lot of country kids. So I'll ask them, have you ever shot a rifle before? And they're like, "Oh yeah." And I was like, "Okay, now you're going to square your body up with the target, just like, you were aiming in on a deer or target or anything like that." And then the next thing you know, they got it. Now they got the body position exactly right where they need to be. And
guess what? What you just said, I think that all the time.
Yeah.
But that deer's always on the run.
Oh yeah.
You're always moving along with that zero.
Yeah, but it clicks in their head, and they're like, "Okay, now I can position my body this way," and they remember it because it's something they can revert back to. So it's like word association, kind of. So once you finished up school, where'd you end up going?
Well, while I was in school, I was working underground in a coal mine, graveyards, and then going to school during the day. So I don't believe kids don't have time for school. Mm-hmm. But after that, I went to a fabrication shop because my welding teacher says I had a hand and an eye for it. Okay, so I went to a weld shop and welded there for a period of time and started doing some night school, taking TIG classes. Well, I got good enough when I seen a job in the paper in Salt Lake, I came and got it. And I mentioned that my first job was stainless food processing equipment for the country of Russia. And that's what we started building and stuff. And the Cold War started up. Mm-hmm. Okay, so that kind of went the wayside. So I went into petroleum and offshore stuff. But then ended up back in Price for a while, which was lucky because I went back to work part-time for my welding teacher at night, building a bronze foundry. When they tried to subcontract him up here in Salt Lake for doing aerospace, because he'd had already went to California and he learned out there and then moved back. Well, he had talked them into let me have the job. That's where I met Bill Komlos and them, but it was building missile products. And why? The Cold War, because of Russia. I point that out because we were building food processing equipment for them just a few years before.
Right.
So, okay, we were working on 2219 aluminum, which is a copper-based aluminum, and X-rays weren't getting, out of 10 parts we do a week, 8 of them were rejected every Monday. But when we started repairing them, the guy I was under, he was out of the Seabees. You know what them Seabees are?
Yeah.
Okay, one, he was smart. One, he could do things good. And man, he could do them fast because that's what them Seabees do.
Oh, yeah.
So We started learning that sometimes we didn't even have to repair where they said was a flaw. They would shoot an x-ray on it and the x-ray would come back clean. But when they would move over and take an x-ray next to it, it was a round part and it wasn't shaped very well. It would show shadows. So we learned to chase these shadows out of that. Okay. And in the midst of it, it was Hercules at the time, come down and did an investigation on what we were welding there because we were having problems. Well, they seen how we were repairing it and hey, there's something wrong. Well, okay, time changed and everything at that job. Later on in life, I read in a Kaiser book in 2 paragraphs what was going on there, that 2219 is copper based. When it solidifies, I guess it's in a prism form. And when you shoot light through a prism, what happens?
It reflects.
Bingo. Yeah, right there. So when we learned, one, because it was rocket propellant and other stuff that might have been on it, around stuff, we had to learn to weld aluminum with no pinholes whatsoever. If you go back and look at the code, and I want you to, and see what it's opened up to in this era. Okay. I think it's 0.39 you can have in that 1 inch of total 16th porosity in there. And here we had to learn to weld it, with no pinholes. And if we did, we had to repair them, which is even worse on aluminum. But we got to where we could actually make it work and get everything polished out and work for them. But that's what makes you good, correct?
Yeah.
I like what everybody says on your program is make the next bead better.
Yeah. That's the one thing that.
Don't worry.
That's the one thing that
my arm off, knowing that I knew where a pinhole was before I ever lift my hood. Mm-hmm. And are you that way? You know what that weld looks before you ever lift it,
I've got a good idea before, as soon as I lift my hood up, I'm like, okay, I need to go back and check that area and really look at it because something didn't look right under the hood.
Correct. It's just that little look.
And I think making weld repairs a lot, that's what makes you a better welder because you get tired of going back and fixing things because it just takes so damn long.
Yeah. And, you being a teacher in structural iron, I'd work the kids with a little bit of dipenetrant. Mm-hmm. But then I'd cross them over into aluminum and have them work with dipenetrant with that. Because carbon still in aluminum, aluminum not having any carbon in it, it is 180 degrees to work with than what you do with anything with carbon in it. And if you understand what I mean, how you can warm up aluminum and drop it in cold water and it makes it soft. Mm-hmm. Well, you do that with carbon still, it makes it go hard, correct? Right. So most people, when they mess up on aluminum, it's because they can't cross over and think different to make that aluminum work for you. Guys like Bill Komlos, and you want to talk about Skills USA, they did me a favor. These kids, because they were going to school, and especially Mason Winters, he was going to become a welding engineer. He would go take these classes. I remember statics class. He was scared of it. And he took it the last semester. And every day he'd come in, I wish I would have took this the first one. Yes. He enjoyed it so much. And while he's there explaining what he learned in school, it filled in so many areas of what I was watching all my career. And that's why that's happening. And I really learned what was meant by surface tension. You know what that is, correct?
Correct.
Well, aluminum holds surface tension even after it's melting. And you want to talk about, I call them the jumping monkeys, where they're jumping on a bed in aluminum. It's these pockets. You could see them come up and push little on the surface. And you're almost waiting for it to pop, but it doesn't. And it goes away. So you roll your arc over a little bit and kind of force that heat into it. And you watch it do it a little bit more. And then all of a sudden it almost settles. Well, that's why I say you got to watch for them monkeys, because them are them pinholes that are going to be on that startup and in places, especially when you got 2 different thicknesses of metals. A lot of them pinholes will want to go to that thicker side all the time. So once I get to that point, then with aluminum, I push a concaved puddle. That's how I learned to do aluminum very well. Instead of having a convex puddle right under you, you push it till it's concaved. Then that's the way you know you have enough heat in that material. Now, if you go into stainlesses and stills and everything, and you run a concave, you get rid of all your undercut. Everything just fills up and it like jumps together. Metals just like roll into place. So now back to the aluminum. You pushing that concave puddle, what's going to happen is you're pushing them gas pockets out. And here's another saying I have. With aluminum, you add no rod before it's time. If you want to push them pinholes out, you get it to that point and it's convexed, and then all of a sudden it drops that concave and you slip one small drop in there and you'll watch that puddle. And you've probably seen it in steel. It kind of boils a little bit and then drops back in because it's fighting that mass, that little bit of mass you put in there. As soon as that drops down in, you'll watch the puddle go to concaved again. And once that starts happening, about the third drop in there, you got control of it. Then I call that your heat hole, is what I call it. It's almost like you're running that little high heat in that aluminum all along, and you're trying to keep that thing pushed down there and packed into place. Guys like Chandler, as soon as they seen what I was doing there, they could outweld me. The next day they were doing better than me, and it was just a matter of being shown. Just one little thing. Mason Winters, I showed him things on one night. 2 days later, he was kicking my production level to the side. It's like, well, good on you, kid. Yeah. So that's why I say that Skills USA. I see some kids come out of there that are great.
Yeah, and that's the one thing I never heard or understood is like, there should be people lined up waiting to give these young men and women a job, or not just a job, but a career. Like if you can weld that good, even if you don't place number one in international, I mean, you're a good welder. You have the skills. Now I just need to hire you at my company and show you what I want you to weld on.
Yeah. And you're a racehorse. Yeah. Like I said, you're already coming out with a stopwatch.
They're production machines.
Yep, exactly.
And everything's done under pressure. So, I mean, how are you going to, you can't really get under their skin. They're calm under pressure because they can perform. Man, I got to try that with the aluminum now. Like just to really kind of focus in. Aluminum TIG's always been like, I can do it. I'm just not the greatest at it. It'll hold, it'll pass, but I want it to, look really, really good.
Okay. Here's the problem you'll run into. You know how I said we couldn't have any pinholes? Well, do you know that there's a limit with aluminum at 450 degrees Fahrenheit? It has 5 minutes is all you can hold it there. Then you've got to be down below that, or you start taking life cycle out of that material, meaning your tensils will start dropping. Okay, so trying to keep that, you can do that. Sometimes you spend a little more time in that, but as long as that thermometer's migrating, you're still confusing them molecules. It doesn't really take. But see, that's what was the biggest problem we had back in that era, was keeping that material still at a good grade. And have to, let's say, like one part I did, it had 2.5 inch thick aluminum, 5 inches tall, 3 segments rolled into a ring. So I had 3 welds, 12 inches in diameter. Now that was welded down to a 3/4 thick plate aluminum. Had to be all 100%, and not after. And after all the 100%, after all the machine and everything, then it had to pass dye penetrant. So there was times that you couldn't even tack things together, because as you'd get them tacked, you couldn't even get the puddle to melt. So what I'd end up doing is heating up steel blocks really hot, get another helper, warm up with the rosebud right there, get it up to about 350 degrees, drop on these blocks at about 600 degrees right on in certain areas. And then I'd start welding, because now my heat ain't running out. It's still, it's trying to come back to me. And then as soon as we get X amount, pull them blocks off and put fans and cold blocks back on it, so the machinist shop always said, man, you guys always warm everything up just so you can cool it back down. Well, You know what face-centered cubic squared material is, correct?
I don't. That's a new one on me.
That's the crystalline structure. Okay, that's your stainlesses and your aluminums. They have very little carbon in them, so there is more theory on the cooling process of that material than there is in the heating process. Totally 100% opposite of carbon steel, correct?
Correct.
You always want to preheat that carbon up, especially if you get an elevated carbon content, you need to warm that up. Well, the same thing with aluminum, but you want to warm it up, but you want to pull it back cold as fast as you can. So my whole career has been cooling things off in this high grade material. That's why engineers send me out to certain jobs, because they know I understand that we got to keep it cold. Everything we weld, we just can't crystallize it. So that's the biggest part. So one of these days, if you're wanting to do aluminum better, go in there and look at them temperatures that I'm talking about and understand that there's a sealing in there that can ruin your metal. Okay. And I think once you start understanding some of that, you'll know how to back it back off. Then you give me one afternoon with you and you'll walk out a lot better.
I may need to fly out to Utah.
I'll show
now.
You kind of what I have to do. And sometimes a machine, our ability to weld anymore is because we got good equipment. Man, I run some millers and I put some torque on them. I mean, I weld some thick stuff. Mm-hmm. I have two of them, two dynasties. And people say, how come you got two dynasties? Well, when things break down, it's right in the middle of a job. And the better the welder, the longer it takes to get it in, mm-hmm. So I always have two welders, one for a backup, but one's usually hooked up for steel or stainless and the other one's for aluminum. So you know how it goes.
Yeah.
Keep your equipment separated and it runs better.
Mm-hmm. So now when you had to do the repairs, like what's the best way to do a repair on aluminum? Because I know with steel, you can just take a grinder, cut it out, no problem. But like when you take an abrasive wheel to aluminum, now you're taking everything, all the crap that's on the top and impregnating it back into the base metal. So what's the best way to open it back up and get in there and keep everything kind of clean and sanitary?
Okay. Have you ever used an air chipper?
Yes.
On aluminum?
Not on aluminum.
Okay. See, another thing, like Chandler said, when he looked in my toolbox and seen some of the tools, and like, what's this? Well, it's tools I made. I take like off an air chipper, a regular square blank that they make for them, and then I carve the end of it. It makes like a little horseshoe down this. Then I polish it, and you polish it till there's no grain in it, so it's nice, almost like chrome. And if you get it angled right, I can take like a weld, like let's say run a MIG gun weld in or a TIG weld in. I can rip that thing out almost as fast as I put it in with an air chipper. Huh. It's just like an air arc in reverse, and it just slivers it right off. And what I've learned over the years, because I've had to weld a lot of things together just to hold them together to start welding somewhere else, is you learn a lot because that air chippers, it's coming out. You can see where it's fracturing and where pinholes are up on corners and stuff. So it's a learning curve. So, okay, I chip it out I get it down to, a lot of times you dye penetrant that and get it down to where there's nothing there. But most of your codes read that you have to remove the skin of where that penetrant's been. So you come in with a clean carbide burr. And do you know the difference between a steel burr carbide and an aluminum carbide?
Yeah, you got less flutes on the aluminum one, so it doesn't gum up, right? Correct.
Okay, so it don't load up. You know how to keep them clean?
Believe it or not, I use soapstone in a lot of my stuff.
Okay, soapstone will work, but that's a little bit of a carbon. I've welded over a lot of things, man. What works best is a beeswax. Okay. One, it burns out easier. So one of the waxes that I use, and I think it's a derivative of beeswax, is Johnson's paste wax. Okay. I mean, it's cheap and everything else, but if I have to lubricate like aluminum or stainless and have to sleeve it together and be able to weld around it, that stuff burns out a lot easier because it's not a petroleum base. So it burns out at a lot lower temperature.
Okay.
So back to the keeping your flutes clean is you put a little bit of that on and carve out majority of it. So now in that repair, you're going to load that soft aluminum up into that carbide. If it's sharp, that carbide, it flips it good. But once it starts dulling, it holds it. Mm-hmm. So what I usually do is have a heavy aluminum block right there to the side. And a lot of times I got it clamped to the. So once that carbide loads up, I'll take that carbide and start running it on that cold aluminum block that's heavy. It'll knock them out.
Because the temperature difference.
Yeah. Then you load that, you put your beeswax back on it and then start carving it out. So my theory is usually if I have pinholes or something like that, I try to go a little bit deeper than that pinhole was to get down there and make sure I'm in there. Mm-hmm. And then if you're doing that repair on aluminum, if you try to run it and do it with a convexed puddle, you almost always have pinholes somewhere on the edge of that puddle. They may be tiny sometimes, but if you go, okay, that's running a convex puddle, you'll have the pinholes. If you go to the concave, you're pushing, and think about it, you're loading everything to the side. Mm-hmm. Your gas, your argon is not able to suck air underneath that puddle. If you understand, when I'm running aluminum, I don't tip much like this, especially the heavier it goes, I'm straight down because I'm trying to keep that puddle there. And when you add your rod, because, being an AC, it kind of flutters the arc and everything else. Well, what it's doing all the time, it's trying to suck oxygens underneath that puddle. So on my starts on aluminum, a lot of times that's where you have pinhole problems. I go to start on that, but I'll come like that and add them first few off the edge, pushing that argon off of this, and then turn my torch into it and start running it that way.
Okay, so you'll aim opposite direction of travel for the first couple of dabs and then start angling it back straight and then kind of a push angle.
Correct.
Okay.
And then another reason that helps you out, because when you add that rod in there, you got to have real good slip, meaning what I call slip, where that rod slips off. So you got to bring it in really close. When you're turning this way, that rod gets preheated and wants to go in easy. Well, now you turn it backwards, you don't got that preheat. So you got to bring it in really, really close, and then you watch that ball up on the end and then slip right off. If you get any turbulence, you got a pinhole. So that's the things you have to watch for, that little bit of turbulence on aluminum, because if you get that turbulence, that's what it's doing. It's trying to grab that oxygen and drag it in with it.
Okay.
It's a flame. Anytime you have a flame, it's always looking for oxygen.
Yeah, and it needs that third part of the fuel triangle.
Correct.
So what, I got a kind of a curveball to throw you. What's your favorite type of tungsten to use for aluminum? Because I've heard everybody's got their own special preference and everybody's got some that they will not use. But like, what have you found in your experience to be like the best, something that's going to maintain that ball, it's not going to splinter or crack?
Okay, well, it comes down to the application. Like today, just to shake it up, it's production parts I was doing today. Mm-hmm. I put in some, what is it called? E3 tungsten. You know what that is?
Yep, the purple band.
Yes, exactly. Okay, the reason I usually use 2% with this, welding aluminum.
Thoriated?
Yes,
Okay.
And the reason why I do that with this job especially is because I've got it where I don't even hold a torch. It's in a holder, and I'm running a little like machinist vise up and down. It's got a fine thread on it. I'm just adding rod and pushing the turning pedal and my amperage and stuff.
Okay.
There's times I go 3 days before I even change the tungsten. And I'll probably do 300 parts, so you're talking 900 welds, and I haven't touched it because I'm not holding it anymore. Mm-hmm. The only reason I change it out is because it starts getting too fat down on the bottom. So my puddle width's too. So I like that E3 if it's high amperage and it's real thick material. I tack most of my aluminum together with 2%. I'll never use a gray band because you just don't have the drive. Okay, when it comes to the production and stuff, and I'm not holding it, I'll use 2% just about all the time. I'll just go over to my machine and turn the balance down to about 30, and it'll ball it up just to where I want, and then go back to what I want. But the reason I use that is because it starts up all the time. When I push that pedal, it starts right up.
Yeah.
Okay, that ball ends up now deforming. And a lot of people talk about spiking, the little balls that you have. Well, I can run 1 day, 2 days, 3 days with thoriated and the E3. And almost every time I can pull that tungsten out and they're almost the same. Them balls always position themselves in the exactly same position. And the reason why is that electricity is always trying to find the easiest path. So I find that they set up themselves up, them spikes, to the positions where that electricity is going to get into that plate the best. So some balls get up here. If this is a thicker side up on your topper edge, the balls will be thicker, more mass than the thinner side. But I'll always get 3 of them, one right in the center and one to the side and one to the side on the leading side. Then I'll get a spike on the back here, spike right here, and usually about 5 spikes, and then one bigger one in the center. And it's repeated itself over the years. So electricity does the same thing all the time. Mm-hmm. The gray band, I use it sometimes when I don't have a tungsten sharpened. I'll grab that out. But no, there's some times where I'll pick it up to where there's just I want a clean weld, and it's not very thick and it's thinner stuff like that. Some of the reason I use that is because 2% is hard to get anymore.
Yeah, it's becoming a little bit more difficult to get because it's got thorium in it and it's radioactive, and there's a huge debate over it.
Oh, yeah. My theory is people get it from grinding it.
Yeah.
If you ask me. And once you become good, a lot of people like grinding my tungstens because there's not much there to grind off, Like Mason Winter said one time, he says, "Oh, a dirty tungsten? That's a dirty weld." Yeah. And it's just so much easier to have a clean tungsten. The electricity goes to where it wants. Mm-hmm. So
that's then the grind angle and then the direction that you actually grind can have a big impact on there too. Because I know if you grind like parallel with the wheel, then it's kind of like speed bumps coming down. But if you kind of sharpen it like a pencil and you've got the tungsten, I guess it'd be parallel with the wheel at that point. You get the line straight in line with the tungsten. It kind of creates a superhighway for that electricity.
Correct. I use a different kind of weld so it doesn't leave a lot of grind mark. Tungsten should always be ground with the grain. Mm-hmm. Okay, so, grinding it like you're saying with the grooves that way. I grind a lot especially if I want a good point stuff. A lot of times I'll turn it to the side though and grind it too. And some people say, well, that causes arc wander. No, what causes arc wander is you ain't putting enough amperage and volts to it, Push that. If you're running a concave puddle, arc wander's gone, because now the metal's soft enough underneath that, the puddle's hot enough that it'll accept them electrons. You talk about aluminum. I can tell if somebody's running aluminum from clear across a shop by the noise it's putting out. If the electrons cannot absorb into the metal, the base metals, what happens? They're reflecting. They're coming back up. Well, you got exchange happening anyway, positive and negatives. Mm-hmm. Well, the ones that get bounced up, what's happening? They're probably bouncing off them other ones. Where's all that noise coming from? And all I know about electricity and heated molecules, there's a lot of energy there. We're just dealing with a small pool, what we deal with. But there's some energy. If I want to bend some metal, let me put a little bit of heat to it and I can make it do a lot of things.
Yeah.
So you probably know all about that, being with big columns on what you can drive around with just a wedge.
Oh yeah. I cut out dogs and wedges all the time. And my buddy, Don Watson, that, he was one of my mentors when I got into ironwork. The sleever bar, man, you could move the earth with a sleever bar. And that is by far my favorite tool. Since I got out of ironwork and got into teaching, I've given away all of my tools to students that are out getting into the trade, except for my sleever bar. That's the one tool I will not give up because I can move everything with it.
The old men used to say something right behind that too. It'll save your back.
Yeah.
You can move the world and it'll save your back.
That was my problem is I was like all the time grabbing something and trying to heave it up and everything. And he's like, hold on, young man, come here. Go get that bar out of my box. I go over there and grab it, and he'd put it in the right spot, lift it up, boom, put a 2x4 underneath there and done. Yeah, you can move mountains with a sleever bar.
Yeah. See, my welding teacher was Gary Prazen, back to the college era, and he was an artist, a great man to me. But one day in class, he's talking about tensile strengths. And him being an artist, at the same time, he was doing some horses. And so he's reading on these horses. So he's giving us these calculations that, well, that horse leg can take X amount of pounds. Your arm can take X amount of pounds. That little rod can take X amount of pounds. Like, huh? Just the size difference, and that metal. Like, then he used to have the saying, either you work the metal or the metal will work you. So you decide. So I was always small, small framed, 150 pounds, and guys like you that could throw things around. He'd just look at me and says, oh, being small will make you smart. Because, I had to move that stuff with the big guys, keep up with them. But I had you guys. I could always fit through that manhole.
Yeah. That's not always a good thing, though.
I did a job. We were going to do a job on my Maraging still. I was talking Maraging still, people call it Maraging 200. The tensile that they were pulling on that was like 215,000 pounds KSG. You can ask Bill about it because he was over that deal when we were breaking them things. Mm-hmm. And the only reason I was getting to do it is because I could fit through the manhole. So we did all the testing and everything and never did the job. So come see, come saw,
Yeah. So now another thing with aluminum is like your cup size. It plays a big part in that. A lot of people don't realize that the argon is going to, or the arc's going to follow the path of the argon. So if you have a big cup on aluminum, you're going to get a lot of arc wander in there. Or you're going to have a much wider puddle.
Correct. Yes, I do notice that sometimes about younger kids when they come in. They run their argon or their gases a little bit too high. And other times it just comes down to, how can I put this? They're going to do like the Skills USA and they're trying to get good colors and stuff. That's great. But when you get out in the field working for somebody, somebody's paying for that. Mm-hmm. They're going to say something about it. So I always tend to use a smaller cup because sometimes I'm using the velocity of it. You go to a bigger cup and it's just like a hose, mm-hmm. how it comes out of a hose. But you neck it down a little bit, you can find that's how I choose cups a lot of times, is the velocity, the speed that I'm getting out of the amount of argon I'm running. And most people don't even cue into that. The reason I got into that was because running aluminum, you've got that AC going, you got so much more turbulence always going. Mm-hmm. So welding aluminum will make you good at, finding how that argon's moving around you. And most of the time, like I says, where you're getting problems, it's trying to drag it underneath. You're long arcing it, or you've got that tungsten out too far. Or I like to run a tungsten out quite a ways, but then if I do that, I have to tip it more. Mm-hmm. And you probably realize that. So that's usually, a lot of times I'll have it up there a little bit close, further up in there, because I'm driving it down straighter into it. And the secret is to that aluminum, if you're doing that, is get that rod up closer and preheat it before you slip it off. That's right. What people try to do. They try to jam it in. And you said one thing, patience. Patience with steel and kids and stuff. If you want to be good at aluminum, use that patience. Add no rod before it's time. Let it do what it needs to do. Because aluminum sits there and resists and resists and resists, and then it lets go. Mm-hmm. Once it lets go, now you can haul aluminum welds fast when you get to that point. Yeah. Remember I told you that heat hole? That's why I'm in it, because that's where your speeds are. If I want to make some money, I'm trying to pick up them welding times all the time. Okay, that's kind of one of the analogies I use when I'm teaching is like you got to get it preheated, get that puddle going before you start adding the filler metal, because they want to hit the pedal and start adding filler. It's like, no, Get that puddle established first before you start leaving, that start point.
It's like your MasterCard. You don't leave home without it, right? You got to get that puddle heated up and then you can start nurturing it along the way. And like you said, once you get it to that preheated temperature and everything's flowing, you can start cooking and moving pretty quick.
Yeah. Okay. And the next thing to add into that is dilution. Do you guys do anything with the dilution? Shooting PMIs on that?
No, I haven't. Okay.
I work at a piping factory, and the guy that ran that place, he's out of the American Welding Society too. Jeff Hugger is his name. Well, he told me one day, he says, Tony, since you started on doing this Inconel, he says, I can't believe there's probably about 4 guys in this whole plant that maintain the same dilution, just nonstop every day. All month, any month I can pick a fitting out and get about the same dilution. Dilution, to me, adding that rod in helps so much because that is alloyed to take that high energy that's, the electricity going there, the shock and everything. And then they've got it alloyed a little bit more than what that parent metal is. So it goes in and does its stuff. So if you want good tensils and good strengths and stuff, make sure you get plenty of rod. That's where people with aluminum, because you're fighting that first add, but then you have to add enough rod once you get going. So what I teach kids is give them a rod, take that rod home and learn to feed that rod while you're sitting around watching TV and doing this. And I says, and once you get it feeding that way,
feed it the other way,
feed it back that way, And I says, you'll find out when you drop that hood, that hand already knows what to do.
Exactly.
You want a pretty bead? There it is. You want a good guitar player? It's that pick hand.
Yes.
It's like, so I see I caught something you like.
That's when every time, so we in my level 2 class, we'll go through flux core self-shielded and gas shielded and then get into aluminum MIG. And then probably like a week or two before we get into TIG welding, I bring in a handful of 1/8-inch diameter 70S6 wires and I cut them all in half down to 18 inches. And then I'll roll both ends just to where they have like a tiny little roll on the end. And then I'll give everybody a piece of TIG wire. And I said, when you go home, when you're watching Netflix, when you're chilling out on the couch, start feeding this filler wire. And I'll show them 3 different ways to feed it. And I said, once you go forward, front to back, then go back to front. Just start working it backwards. And then once you get good with that one hand, put it in the other hand. So if you're left-handed, start feeding it with your right. If you're right-handed, start feeding it with your left. And then once you get comfortable going back and forth, switch it to the other hand. And I want you all to do that before we get into TIG welding. And then I let them do autogenous for about 3 or 4 days. And then we introduce filler metal. And then I can tell the ones that have practiced it and the ones that didn't. And I'll ask them, I was like, did you practice with your filler metal? No. I said, yeah, I can tell. Because your hand has it's a foreign object in your hand right now. Your
no
hand
rhythm.
You've got no rhythm.
Yeah. The next thing after that 1/8-inch rod, hand them a 30,000ths rod.
Yeah.
Yeah. See, because that is a pain in the neck to try to stay steady down there.
It is.
And feed rod. Most people throw off that glove. I cannot stand the smell of burnt skin. I smell it at night. Like if I burn my wrist, because of cuff and stuff, I'll be sleeping and I know I burnt my skin.
Man. Yeah, 30,000ths, that takes a little bit of, I dropped down to a smaller glove that's not really meant for TIG welding. Kind of like those, they're like form-fitting, like neoprene, or not neoprene, yeah, it might be a neoprene. But they're kind of like just general work gloves, but they're really form-fitting, and they got texture on one side, and then just fabric on the back. That's typically what I use if I got to do like a lot of low amp or 30,000ths. Like I repair a lot of like fryer baskets, and I use 035 TIG wire to do a lot of that, because it's just like, small 1/16 diameter pencil rod is what the whole thing's made out of. But it's just like little tacks here and there, and a couple little 1-inch welds. But that's typically what I use because I got to be able to feel that wire.
I had times that I had to climb down in tanks and stainless tanks and have to weld stuff. So I'm feeding this 30,000ths wire hanging over the edge of the tank, welding down in there. The best way I found to feed that rod.
How's that?
Go for as far as I could and then kind of tack the rod to the part and slip my hand up and then melt it off and go again. So,
that works.
Whatever works, you know.
You just hold on to it and just kind of feed it in and then let it stick and then slide back. I've done that a couple times. Yeah.
Oh, yeah.
Not on the 30,000. I've done it on other like 1/8 inch and 1/16 and stuff like that, just trying to get repositioned or have to work your way around something. You just leave the rod right there in the puddle and kind of back off the amps a little bit, just enough to get it to stick so you can move your hand and get re-gripped.
Let me ask you a question. Do you do anything with the art side with the metals down there?
As far with like artwork?
Yeah, doing any kind of artwork and stuff like that?
A little bit. Every once in a while I get a student in the program that, I mean, that they have that artistic ability, and I'll notice that because like usually Thursdays we'll have project days, or, you know, they can come in on Fridays and do extra time, and I'll have them, you know, I'll see them go back there towards the scrap bin and they'll just start grabbing stuff and putting things together. I had one female in the class. I don't know if you're familiar with the Nightmare Before Christmas with Jack Skellington.
No.
It's I can't remember who put the film on, but it's like a claymation type movie, and she took a ball hitch from a truck and propped it up in the vise, and she carved out the entire face with an end grinder and a burr bit, and then built the whole body from them just out of scrap metal, and the thing looked amazing. But we get a couple of artists in there every once in a while, and then the guy that I just hired, Malachi Tangard, for our daytime welding program, he does some really cool artistic stuff, and that's one of the reasons I wanted to bring him in, because I'm not really the artistic guy, but he's got that vision. You know, he can look at a bunch of scrap and just see stuff that I can't, and so he's kind of working with the students and kind of bringing that out of them.
Well, the reason I asked that is because that's kind of what made me good, is building that bronze art foundry. And seeing, okay, I learned how to melt metal and what the lost wax process was all about. But then you was welding John F. Lewis and Kennedy and stuff, you know, people and stuff. But a lot of the people with the space industry have said, you're an artist at this, you know, because whatever they hand you, you got to do, and you got to make it look right. And because there's a lot of people that look at stuff, you know, like for NASA and stuff like that. So that's why I say pushing them people to think off that other side of the brain, to me, has helped me with welding so much, because not only did it make to where I could make that weld, I could make the tools to help me make that weld better. It's kind of like Chandler has a little thing he sells on the internet for holding your hand while you're doing these welds. You know, you can buy and I called mine the golden arm. You know, Mason, when he seen what I built to where I could flip it around and you could put your arm on and just weld, hold your hand on it. People used to say, oh, that's cheating. Man, after about 12 hours of welding, no, I need that. My arm, I can't hold my arm up.
That's not cheating. That's thinking smart.
Well, no, it's just you got to be steady and comfortable. That's what welding's all about. But welding is an art. I don't care how you cut it, because you're fabricating, you're building stuff all the time, and it's an art to try to make it right. Like if you're looking at the shrinkages and the warpages and stuff, it's an art of going to the pile, and just like a carpenter, finding the crowns and putting them, because, you know, if I weld on this side, it's going to pull that plate that way. So I'm going to put the bow the other way. So it's a chess game to me. A lot of parts are a real chess game, and I love my job. People say, when are you going to retire? I'm still having fun, man. I'm still practicing. So
that's a good way to look at it too. I hope that I never just sit back and retire. I want to weld all the way up until the end, just because I enjoy doing it. I'm passionate about it. I know that when I flip the arc down, that's my time. It's everything else goes away. It's a very calming effect. Even like no matter what's going on, you know, once you get everything prepped and set up and you flip your hood down, you're in that moment, and nothing else matters. Everything else just fizzles away, and it's just you and that little puddle.
You're on stage.
Yeah, exactly.
It's your time. Yeah, I'll never tell you how to spend your time under a welding hood. Once you lift it up and it don't look right, I'll, you know, make suggestions, but however you do it, there's 100 ways to do the same part. I've learned from different shops. You walk in and you look around and you start saying, well, what materials and what tools do I have to work with? Because some shops are set up great. In other shops, you're a caveman. You know, I'd walk in there from doing something aerospace to doing something that was almost blacksmith, which it's an art too, but it was just so much dirtier. I don't know. Back to the art piece. You seen that, Joe? I sent you that one picture of me and that.
Really neat.
That started out as two Steelies, two ball bearings that I welded to a rod. And then I built everything, measuring people and stuff. And I'm going to get him done before I retire. That's my goal.
It's a really cool piece.
Well, I've got a lot of artwork over the years. A lot of pieces. So I look around at my family's house, my brothers and sisters, a big family, and I see what's on their walls that I gave them. All I know, I used to be ambitious when I was young. That's all I can say, because there's a lot of stuff out there, and that's what makes you a good welder is windshield time. Just do it, and do it. Now back to the art with your students. Have them weld some dissimilar materials together where they're fighting each other, where they have to learn to be a herder. Herd that thing right down there, because that part over there is not going to want to take it. Mm-hmm. So that's some of the reason I'm pushing the art end of it, because it pushes you into places that you're not going to see in the common world. And if you can do something that's out of the ordinary, usually common's pretty easy.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by AHP Welders, which are the ideal machines for students, home hobbyists, makers, and those looking to weld on their own. You can get into MIG, stick, and TIG right now for under $1,000 without having to sacrifice performance. I've used these machines several times in the past, and they perform great. Get your AHP machine today at ahpwelds.com. We're also brought to you by Strong Hand Tools. Head on over to stronghandtool.com/ArcJunkies and see what additions you need to make in your shop to increase speed and accuracy. I used my Rhino cart once again this weekend to fix up some parts, and it made my life so much easier. My favorite part is, it's on wheels so I can roll it anywhere I need to in my small shop. Check them out today and see how they can help you on your next project. Now let's get back into the show. So how did you get into the other exotic types of materials that you've welded? Because you've got like a litany of different types of material that you've welded. Like most of the stuff I've ever done was all A36, steel, and 6061 aluminum, or 308, 309, 316 stainless. But you got a bunch of numbers. Yeah.
Well, what happens is, remember I told you they did a study back in the 80s on the 2219. Mm-hmm. Well, we got to sit down with about 4 engineers for about a month and a half, where they just watched us and stuff. And here's what I come to learn. Every welding engineer and almost every engineer out there has taken a welding class. Then they come and sit with you for 3-4 weeks. These guys that are welding engineers start looking at you and say, man, you got a hand and an eye for that. So after you impress them right there, and after doing them studies that we did that aluminum to that point, that what ended up happening, they started throwing all kinds of materials from around the planet at us, just different stuff to weld on, out of the oil industries and stuff like that. At that one point, we were welding 15,000 stainless to Monel rings. Oh man, I can't even. Different kind of Inconels, different kind of high carbons and stuff, just to see which ones would hold together the best. Mm-hmm. And made some good money out of that, but it was dissimilar metals. And that's what they always had a hard time, is people that could do dissimilar metals, but 15,000 thick, there's not many people that could, would even step up to it.
Even on similar metals, that's a difficult material thickness to be welding.
Yeah, but it's all in the setup. Mm-hmm. You work around me for a while, and you find out I set it up so I can't fail. And that's what it is. We make it so easy to weld that you can't mess up. So it's not so much how to weld it, it's how to make it to where you can weld it.
Yeah.
And if you want to do stuff for space, you need to always be thinking out that other side. That's why I'm saying I want you to teach artwork out of this, because one, we're going into a different generation of things now. Cars are changing, mm-hmm. Transportation's going in. We're going to go into space a lot more now. So some of this stuff hasn't even been invented. So that's why I'm trying to get these kids to think outside the box, because we're not going to be here to tell you all the time. And I know you can look it up on your phones and stuff like that, but you need to think by yourself, because you know how it is. Once you start doing something, it becomes easier to do. Mm-hmm. And the art side, I think, just makes your hands work.
Right.
makes your ears work, makes your eyes work, and just really makes you sit back and you are on stage, not just with dropping the hood. You're on stage even with the hood up now. And that's what I'm trying to get around, because them kids are going to build parts. You know how it is going out to work, and every day you're laying down bead or making sure that it's on mark and trying to keep it where you don't cut things out. Mm-hmm. And these kids, that's the worst thing that the thing I see they don't like to do is sweat and get dirty. And so I'm trying to teach them ways of, well, you can do that without having to really get sweaty and dirty. You just got to be a lot smarter. You almost got to be a journeyman to do that. But if we can do that in their thinking, I think the rest might come with it. But maybe I'm thinking wrong.
No, that makes a lot of sense.
I heard how Chinese teach a lot of their kids. They let them play and do whatever they do naturally for like the first 8 years of their life. And then they start making them do the other work. But by that time, they already figured out what them kids like to do. Well, that guy's good at math, or that kid's good at sports, or that kid's good at drawing. So I think that's some of the problem with these kids. We just got too much out there that we can pick from. We don't really know what we want yet. Mm-hmm. And I'm still there at my age. Man, I don't want to retire.
Right. I was talking to my nighttime welding instructor the other day, and we were talking about how they do it in Europe. So apparently they've got like what they call the German apprenticeship program, to where at like the age of 12, they kind of identify where these kids want to go, and so like this group of students here, they learn better kinesthetically with their hands. So you're going to go into skilled trades. You're going to get into plumbing, pipe fitting, welding, electrical, all this stuff. And then, hey, you're really good at math, so we'll put you over here, find something that's really heavy in arithmetic, or or engineering or something like that. Or like, hey, this kid's really good at reading and absorbing information and taking it all in and being able to regurgitate it. So you'd probably be good for the medical industry. And they just kind of, they support that growth, and they kind of identify where the strengths and the interests are. And then they help promote them along the way. And then over in those countries, your plumber and your doctor, they're looked at the same level. We don't do that here in the U.S.
Well, sometimes I think we got too much to pick from.
Yeah.
It's not materials right now. Materials are really hard to get. I don't know if you guys have that problem, but up here we've been having problems. Getting material takes 6, 8, 10 months to get to it. And now I'm starting to see materials change again. And they're going back to materials were here back in the 70s. Just because we can't achieve what we have here, well, we're going to build it out of this because we know this will work until we can get these materials in. Mm-hmm. So there's going to be a boom. You ever heard of a material called 304H?
304, no.
You hear 304L all the time, right?
All the time.
Well, I've seen 304H in books all the time, never done it and stuff. Well, we're back to 304H.
So what's the difference between 304H and 304? Is it like a high carbide precipitation?
The L is for low carbon and the H is for high carbon.
Okay.
So yeah, they're worried about me having carbides in it, but I keep everything so dang cold when I put in the pass and then cold, chill everything back down. I usually don't have any problems with that.
Okay.
Just because I maintain really low inner pass temperature.
And then how do you chill it back down? Just like different blocks and stuff like that? Correct.
Yeah. Cold aluminum blocks a lot of times. I'll chill them off like in the refrigerator, and I'll be trading them out. So I come and I can put them down. But what that really helps out too, it picks up your production time. Because the faster you can get it cooled down, the faster I get it back to welding.
Onto it, yeah.
So at one point I was doing some material called NVAR. And, you're asking about the array of materials.
Yeah.
NVAR is a tooling material. So it doesn't fall under the same categories as like your structural iron does, because it's a tooling material. Well, I'd go out to this plant to where you couldn't have any foreign debris out there in the plant. So, no lunch buckets and stuff. Well, they knew I was coming in, all the big engineers and the contractors got me to go out there with a lunch bucket full of cold blocks. And I'd sit it right in the middle of the aisleway because, 100 yards that way and 100 yards the other way, 2 or 3 inspectors seen it. And next thing you know, there's people over in my department. Hey, you can't have a lunch bucket out here. Well, grab one of them sandwiches, and if you can bite through it, you can marry my wife. They'd open it up and see them aluminum blocks, but that was the whole trick. I had to keep that material, 1, cool, to keep the structure right, but 2, this thing I was building was huge. They couldn't have any warpage on it. So that was another reason.
You got to keep pulling that heat out. Yeah. That's we use we did a field trip to a company, and they do all kinds of electrical stuff. So they have like these big, thick copper chunks like for bus bars, and so they've got this big scrap pile over there. Once they get done cutting it, they send it off to recycle because they can't weld them together. It's just like the off pieces when they make these bus bars, because they run it through a machine and it gets bent in all kinds of different configurations. So I asked the guy, I was like, hey, what are you doing with that copper over there? If you wouldn't mind, I'd like to grab a couple pieces. He's like, oh, yeah, I bet you would. Scrap prices are through the roof. And I was like, no, I can use those for chill blocks. So when I teach the students like really thin gauge stainless, because we'll do like a lot of 040. We have a couple companies that need students to be able to, or need employees that can weld like really thin stainless. I say really thin. You're talking about 15,000s. I'm talking about 40,000s. But that's what we'll use we'll use copper blocks. So like when we do a lap joint, I'll put that on the bottom. They'll do their lap joint right on top, and then I'll take that other copper block and set it, within a 1/4 inch of that leading edge, just so it's constantly pulling that heat out.
Mm-hmm. Exactly.
And it works really good. And then when we get done cutting up test plates and stuff like that, I'll grab them copper blocks because I don't want them to chill their, the pieces that they cut off. I don't want to quench them. I'll throw those copper blocks on there. We'll talk for about 2 or 3 minutes and then pick it up in the room temp.
Yeah.
Just because it's
same
a
thing
big
with
heat
aluminum.
sink.
I use aluminum a lot. Do you know what Bill Komlos did for his thesis?
I don't think.
Have you?
Yeah, I don't think we got into that.
Look into that.
Oh wait, no, I did. Because he was cooling like structural welds.
Correct. He rocked the world.
He built
what he come out with rocked the world.
I wonder where. Do you know where that would be available?
Probably call him and talk to him.
Okay, I want to pull it because he explained it on the podcast, but I want to get like a little bit more in depth. I didn't know he had it all documented and everything.
I tell you what, he stumped some people at the university.
Yeah.
They couldn't figure out what he was doing, and when they finally caught on what he was doing, it, like I said, it changed things. The old saying: if your elongation goes up, your tensile strength goes down, and vice versa. When they seen both his needles go up, they were trying to call BS on him.
Witchcraft.
Oh yeah, So he had to fight tooth and nail to get it pushed through. But now that it's through, he's the man.
Yeah, he's a very smart individual, man. I had a blast talking to him, and he was saying like you're the go-to guy because we got onto the Perseverance, and I guess he kind of wrote the procedure, but you were the man behind the mask, and you welded it all out. So what was that like trying to weld a man-made, or I guess it was just like a newly invented metal for what they were doing? It's almost like in a powdered form originally, right?
Well, it wasn't a bar form, but it looked like like a barred powder. The thing with first thing we had to do is we had to pull tensile strengths on the materials. And by the time we did that, I actually got good at welding it. That was harder to do that test work than it was to do the actual parts that I did do. And see, they were afraid I was going to have pinhole problems with that. Mm-hmm. And I think they had only like 3 or 4 rejected parts out of it. And they had me repaired 3 of them just to see if I could repair them, and which I did. But the pinholes that they were looking at, you couldn't see them with your naked eye. I mean, it was, for me to do the repair, it was just turn it on about 15 amps, hit the pedal and back off. The job that I did for the Perseverance, probably average time of that weld was 7 seconds.
Really?
Yeah, because it was a 40 thousandths wire that was welded. All I was doing is securing it to that powdered pin, the CFY is what they call it now. And you're talking about radioactive. I think that Y is yttrium, and I think that's radioactive too.
Okay.
But I read in the books that I do have at the shop, and finally one of that Joe Hartvickson says, you won't find that in books. So I ended up, just doing what they told me to do, the best job I could, and it happened to work. So remember I told you I was lucky?
Yeah.
Oh, I'm a lucky. Don't worry, dude.
I don't know if it's luck, man. I think you're being modest.
No, it's pure. A lot of it's luck. Luck to have people like you, kids around me. Man, I've had a good life. So, but a lot of it comes down to back in the beginning. It all goes back to what you're doing with the kids. I come out of college and went into that fab shop, if you can remember. Well, I'd been working there for probably 8 months or so, and they got a stainless job. First stainless job that company had got. They come out and they says, I used to have a big afro. They used to call me Burrhead. Hey, little Burrhead, you said you can weld stainless at school, right? I said, yeah. He says, you know anything about it? I says, yeah, it goes through a gamma process where the inside becomes the outside and the outside becomes the inside. And if you hold one too long, it burns it off. Yeah, what do you know, little Burrhead? So we went to break. It was break. So the next morning, I come in because I went home that night. I went and got the book out, and sure enough, there was 2 paragraphs right there. I come in the next day and I sit in front of them guys. I go and wash up and come back out, and one of the older guys says, wow, Burrhead, you about recited that. I said, well, yeah, I just took it in school, the past year. So we leave that break room, we get out there, and one of the other older gentlemen comes in, he says, we all know how to weld here, but we learned by hard knocks. You know the theory. You teach us a theory, we'll keep you out of the hard knocks. They took me under their wing. They showed me all kinds of stuff about carbon steel, how to put things together, and there you go. I'm a lucky man. To have these old boys, just the right time, the right place. Here, Tony, we'll help you. Mm-hmm. But now I'm down to the kids. I'm the old man. So I want these kids to be successful. I think the only way they're going to do it is work hard. I mean, you know how it is, going out and holding down your job and keeping up with the guy next to you that is probably twice as good as you, and not make the guy next to you look quite so bad. So we all worked hard to where we got, these kids need to do their part too. It's just going to look different. Yeah. I work with these guys from Mars, doing the Mars stuff, and don't look like they're working hard. But back to the art, they're thinking of stuff we haven't even seen yet. So I think that's where America is right now. We don't know what we're going to do yet, but I think we'll find it. We'll figure it out. We're Americans.
And that's one of the things that I tell people on the show all the time. It's one thing that I tell students. It's one thing that I tell people that reach out to me. Find that old guy in the shop that knows how to do it, that's been there. Keep your mouth shut and be humble about everything that you know, but treat that old guy with respect, because he can walk over there and just tell you one thing that'll make your life a lot easier. He can tell you how to cut that 8 hours worth of work in front of you, cut it in half, just by one simple little trick. And the amount of knowledge, and that's what we're losing right now in this trade. Like the older generation, the average age of a welder is 56 years old. So they're retiring soon, and we're not backfilling that as much. So once you get in, man, you really got to hook up with the old timers and pick their brain and learn everything they're willing to teach you.
Well, I'll give you the offer anytime you want to come to learn how to weld aluminum, or even some of the projects I get going through the shop. It's not very big jobs anymore, but like that Jeff Taniguchi, I invited him in one time. I says, Jeff, I'm building a cryogenic tank for mission research. You need to come down and look at this, because that's where we're going with aluminum. And he did. He come down and sat down and watched me for a couple of days and stuff. And he went back, and here I amazed my friend, that what I could do with metal. Here we went to school together and college together, but he was a teacher and I'd been out in the field. And the respect, back to the respect, them kids, if they respect themselves, they'll be able to respect that old man too. Mm-hmm. So that's what it comes down to, is just like you guys say, make the next bead better than the last one. And if you can't find nothing wrong with it, let me take a look at it. But we all have to be our own print checkers every day. Our print every day is what we put down to metal. My signature on aluminum is a little tit on the end of the weld, at the very stop of the weld. And I have companies sometimes say, how come you always leave that? Well, that's my signature. Well, if you sit down with aluminum with me and a little bit of dye penetrant, you'll leave that tit on every aluminum dill, because I can just show you one little thing what's happening there.
How do you do that? Because the majority of the time, it typically leaves a crater in there, and that's where your crater cracks start.
Yeah, that's hot short cracking,
yes.
Correct?
Yes, sir.
That's why you leave that tit. You want to bring that up. So if you get called out on it by an inspector like you that wants to make my life miserable today, all I have to do is go cut that little tit off. Mm-hmm. Okay, it'll pass. If you understand what I mean. I've chased so much dye penetrant around. I kind of know by the mass how much that crater is going to pull off. And most of the time, too, I'm fading out pretty and adding that dilution in there to get that shrinkage so it don't happen like that. So every bead that I put in, I'm always trying to fix it before I even have to fix it later. That's the way I look at it. Do it right now. Do that fixing right now so I don't have to grind, don't do anything later on.
There was a gentleman that posted on LinkedIn the other day talking about how they were running some flux core. They did a flux core route, and then they did some sub arc over top of it. And one of the guys said, hey, looks like there's a little bit of slag in there. Let's go ahead and clean that out. And the other guy says, no, we'll just run the sub arc over top of it. It'll burn it out. And as I'm reading the story, I'm like, no, go back in there and clean it out. It's going to take you 2 minutes to clean it out, or you're going to spend 2 hours later cutting it out and then re-welding it. And people just don't understand. They get this mentality. And tell me from your experience, because you've been doing this a lot longer than I have, you don't burn slag out. You just cover it up.
Correct. I think that penetration most of the time is probably 30 thousandths, maybe to 60 thousandths. Mm-hmm. And 60 thousandths, you're really digging into it. But from my experience, you're not really burning down that deep into it. It may look like it, but the problems you have is if you get something down underneath you, you got something wanting to boil. As soon as you get that boiling going on, and then you got arc there, what is it doing? It's looking for oxygen. Mm-hmm. So just like you said, you can cause yourself 4 hours worth of work, or you can just fix it now in 10 minutes, Yeah.
Just clean it up.
Suck it up.
It's not going to, people think that they're like, oh no, you'll burn it out because otherwise, when you weld over top of it, it'd keep propagating it to the surface. Now, I mean, that does happen. You can pull slag up to the surface, but the majority of the time, you still have slag underneath that weld if you didn't clean it out. Yep. And then it's even worse than a cyclically loaded structure, because now that weld wants to start opening up, because now you've got that pocket in there. So you put things under pressure or cyclically loaded, and it's going to start propagating. It's going to start spreading and cracking.
Yeah, I agree.
They say, what was it? An ounce of prevention's worth a pound of cure?
Well, I think it's 10 pounds of grinding dust, ain't it?
Something about like that.
At your feet.
Yeah. Especially after having to chase it out after a sub arc, man. You can put a 1/2 inch thick weld in with a sub arc.
Oh, I try to stay away from that kind of work.
Sub arcs?
That's too heavy for me anymore.
Oh, they're fun.
Oh, I know. I've ran enough of them on piping that the worst thing was trying to load the wire on top of the spool above all the pipe and everything. You know what I mean?
They're because it's 60-pound spools, man. Well, the ones we get are because we have 1/8 inch diameter, so we teach a little bit of it at the school. But that's one thing I want to do is, like, now that I've got time, I want to pull put a pipe rotator up underneath it and weld pipe in a single pass. Do the root fill cap in a single pass with the sub arc.
Good on.
I just got to time it out now. I've got the rotator and everything set up. I just got to get it all timed out and figure out exactly how to do it.
And get the right joint design.
Yep.
Sounds like it.
Yep.
But that and a good set of steelies.
What's the steelies?
Oh, a good set of nuts.
Oh yeah. I got you.
You know what I mean? If you're doing a root and a cap at the same time, well, good luck.
Yeah. I've seen people do it. I don't have a whole lot of experience with sub arc. Just doing regular joints in a straight line, that's no problem. But doing it on pipe, I think that's going to be a different kind of animal. But I think it's something fun to play with.
Yeah, the only problem I've ever had on sub arcs is at one point on some startups, you'd get some pinholes. Mm-hmm. And what we ended up doing is building a couple purge dams. and bled some argon right over the top of it, right in that area.
Really?
Never had it anymore.
Okay.
Yeah, it was just dragging oxygen. Like I said, that you get that heat in there and it's looking for that oxygen, and that's, well, you end up with a few pinholes that just enough to get the grinder out.
Mm-hmm.
So I'm always trying to fix it before I do it.
Right.
So spill that argon on the backside of it, and God, Tony, how'd you get that where you don't get pinholes? I don't know. Lucky,
I guess.
So then I'd tell them, but it's kind of like one time I was welding some Inconel, and they wanted the cap with stick. It was out to some petroleum company. So you'd do a TIG root, a TIG hot pass, fill it up with flux core, and then cap it with a stick rod.
What's the purpose of that?
Just some people, some engineers have their, and it might have worked, whatever environment it's in. Okay, so in doing this, I happen to have a machine, an old Lincoln that's got an AC too. It's not just a decent machine.
Mm-hmm.
I put that stick rod, put it in AC. Well, up until then, every time you'd weld on this in DC, you'd get these, the popping out because it's Inconel and it's not wanting to absorb that material. It gets splatter out and get on the pipe. And you know how splatter sticks to stainless pipe or stainless splatter sticks. Well, I start running this rod like, man, I got to turn it up a little bit. Like, oh, what? Why does it look so different? So I turn it up a little bit more and it goes in. And I lift my hood and the flux is peeling right off and there's no pinholes and stuff. Well, oh man, that went in nice. Oh, I went home that night and read in the book that, I could do that legally. Mm-hmm. So, okay. After about 2 days of doing this in that weld bay, all of a sudden the guys that clean up the pipe, how come Tony's don't have splatter on it? Well, there's that Jeff Hugger out. Tony, there's a question going around the shop. Why don't you got splatter? Well, Jeff, if you're gonna have to hear it, you might as well hear it from me. I went and showed him, and he looked at me and he says, the old books would have told you that. The old books would have told you on that large electrode, flip it into AC rather than do it in DC, flip it because you have that 50-50 instead of the 1/3,
right.
2/3. So, man, I tell you what, that one bay got to do all the caps after that, in which I didn't want to do anymore because I don't like stick rod.
No.
I like TIG rod.
Gives you the heavies. I love stick weld. We did. I know they do a lot of AC 7018 in Europe, but they'll run it on pulse.
Yeah,
and they'll do a lot of like open root pipe with that. So that's another thing that I want to try out. We did. I seen some guy do it on YouTube one time, and I was like, AC stick pulse for 7018. Like, why would you even want to do that? And then I got to thinking about it. I was like, well, that'd be good for eliminating arc blow. And with the Lincoln we have at the school, we got one of the Aspect 375, so I can actually dial in how much amperage I want on DC negative and how much I want on DC positive. So we did an experiment, and I basically told the machine I was gonna do some AC TIG, so I had to use the foot pedal, and I hooked up the stinger, and we did AC. You have to step on the foot pedal to get it going, but after that, you put it on the 4-step. So as soon as you strike an arc, it just stays, and it just the whole way up, and it lays a beautiful bead.
I'm a believer in pulse.
Mm-hmm.
I really am. It especially at my age, it's actually a good crutch for an older guy.
Right.
But I've been using pulses for years, and I like the structure. The material has a good grain structure in it when you have pulse going on.
I like the pulse because it gives me like an automated indication as to when to add my filler metal. So it's kind of like you were talking about earlier. You get into a rhythm. So you've got that. You set it to like 1 pulse per second or 10 pulse per second, and you just kind of get into a little rhythm, and that's when you dab.
What I found out with stainless is that pulse. A lot of times I'll put it on about 30 pulses per second.
Yep.
And that shakes. The edge is just enough that it wets it out for you.
Mm-hmm.
You know what I mean? It's going in there, and where before I used to shake it a little bit myself, to keep that agitated.
Yeah.
That's why I was always a good welders, because back the old stick rods, you have to agitate it.
Mm-hmm.
Well, I'm an agitator. Well, I'd do the same thing with the TIG, but then when I put it into pulse, I didn't have to do it. I could steady out. Then I could start going to where it wasn't. I'm more semi-automated with it now.
Okay. So
and then
Oh,
go ahead.
Oh, no, go ahead.
No, I was just going to tell you the pulse now, just like you said, it gives you that rhythm like, oh man, a machine did that. Huh? Oh yeah. Uh-huh. Yeah. I got a CMC, complete Mexican controlled in there.
That's a good way
Sorry.
to do it. No, you're good. So out of all the different alloys and stuff that you've had to work with, or you've had the chance to work with, what was the most challenging one?
Aluminum.
Aluminum, really?
The reason why is because of the mass. Remember I was telling you that big stuff I was doing?
Mm-hmm.
To where it sometimes, that was such a bear. I ended up going back to books, and 2 paragraphs out of the Kaiser aluminum book, you can DC straight polarity aluminum. Like, huh? So that's how I ended up having to do all the inner passes, all that thick stuff, just to hold it enough to start putting AC to it, where I could do. So I would go in there, and how I ended up having to do it in DC is running 75% argon. Well, sometimes 50% argon at the start and 50% helium.
Mm-hmm.
And then after I get that first 2 passes in, then I'd go to 75-25. But then I'd blend off the tip and go in and weld just like you would steel or stainless. And it goes in. And if you want to learn how to weld aluminum and get good at welding aluminum in AC, learn to weld aluminum in DC, and AC is so dang easy because you got all that heat coming up. And when you try to add that rod, it just does not want to go into that pool. You've got to sneak it off into there. And so I'd end up having to put probably 50 passes in that 2.5 in just to get it thick enough to where I could start with the other stuff. The thing that scared me the most about that job is they shot no x-rays or anything. I had to wait for the results until they were finally machined. I mean, so the first one I did took me 2 months to build. The second one I built took me 6 weeks to build. The third one I built took 4 weeks to build. So I got that much better at it. But that whole month was learning. That first one, it was all have to go home at night and read, or after I get off work, go home and read, and, you know, like, what am I going to do? You know, here I'm supposed to be the man to put this together. And I got it together, and it just, you know, it took some time, but it's that stuff scares me.
Yeah.
Because one, I just don't think I have the ability and the patience to do it, because there was a lot of stress on that. But if I had guys like Mason Winters and Chandler doing it, I'd probably take jobs on like that every day.
Now, when you ran DC negative, did you have to run like a larger diameter tungsten because of the heat?
Oh yeah, I was, probably had a 532 in, if I can remember right, and had big gas cups on it and stuff. It's just a matter, like I says, you got to have everything clean, because you don't have the cleaning cycle. That's why you weld stuff in aluminum, because you got that cleaning cycle. Most people don't understand that them positive electrons are jumping from the base metal up. That's lifting them oxides away. Talking about oxides, you get to welding with aluminum, wear masks, wear safety glasses. Think about it. Everything, your sandpaper, good sandpaper is what? Aluminum oxide.
It's hard.
A certain portion of that oxide on that aluminum is just under the hardness of a diamond.
Yes.
Okay, so some of the reason I don't like doing that heavy stuff is the grinding and the dust that gets into my eyes and stuff. After a couple of days of working with the heavy aluminum, my eyes are so bloodshot just because the irritation of the dust in the air. So I have religiously, you can ask all the welders, have been wearing masks since the middle of the 80s. People used to call me names, like, what am I afraid of? All kinds of stuff. But as time went, other welders started doing it. And now the ones that have retired says, Tony, we wish we had done that 10 years sooner, because all of them have, lung problems. We've dealt with such high grade materials with the nickels and the chromiums, the oxide problems, that I'm a believer in the masks. So push your students to wear that, learn to wear them, because that's their health.
Yeah.
here's something that as you get in your teaching further, every good welder ends up becoming honorary. Have you noticed that? Mm-hmm. If they're really good, a lot of times they get to be bears to work around. They're real ornery and mad. I've told this to Komlos. I think a lot of that is toxin buildup in the people. Because when you're a good welder, you're like a moth flying into the Coleman lantern. You're going to do it. You're going to push your head to see what you want to do. And then you end up getting all them toxins and it builds up. And next thing you know, you're ornery. I find I do that too. And I have to go just decompress. Mm-hmm. And so in one of your studies, that's something to study. I tell Komlos all the time, they need to do a study on the aluminums again, because there's a difference between welding aluminum for dye penetrant and welding aluminum for common structure. And we need to define them for the welders coming down the road, because if we're going to space, you thought the welders were good before, they got to get better. If you want to go to space, we just got to get them better. One pinhole is that much more critical. The inspection is twice, 3 times. Can you imagine that Moxie part that I built? How many people touched it before it ever went up there? Mm-hmm. Probably thousands of people probably looked at that thing. And man, I guess I'm glad I didn't think of that stuff when I was doing it, because I would have probably got nervous.
Yeah.
But I want to keep your kids safe too. That's one of the things I noticed. Some kids, they're like I was, gung-ho when they're young. Mm-hmm. Need to slow them up a little bit, and the only people who are going to teach them are the leaders. The reason I wore my mask is because my brother worked in a hospital that he ran into some stuff on chrome factories in the 70s, the beginning of the 70s, and the cancer rate in California. They could see from half a mile from the chrome factory to 1 mile to 5 miles, the cancer would just, was out from that. So he talked me into wearing them. So I'm a believer in them.
Yeah, I think that was the that whole Aaron Brockovich movie. I think that's what that was about. But when we get into the aluminums and what they, I guess, considered exotics, aluminum and stainless, they say that aluminum's been linked to, or welding on it and grinding on it's been linked to Alzheimer's, and then stainless because the hexavalent chromium that links to cancers of all your major organs. So lungs, stomach, kidneys, liver, gallbladder, like it's all being traced back to it. So that's one of the things we've got at our school. We have the at the source fume extractor. So we keep it right there within the welding zone, and then use MERV 16 filters on the inside of our fume extraction system. So fume extraction is huge. We talk to the students and talk to them about respirator use. One of the things I've been trying to do is have them go out and get a spirometry test and then do respirator fittings and all that stuff. That's, what I had to do in the ironworkers all the time. And if you do, a lot of people, I'll see them out in the field and stuff, and they've got like a beard like me, and they're wearing a respirator. And it's like, that's not going to do anything for you. That's defeating the purpose. If you're not going to shave your face, put on a PAPR system. Keep that stuff out, because you've got to get a proper seal. If you don't have a proper seal, you're really not doing anything, So, definitely using some sort of fume mitigation, whether it's at the source fume extraction or a fan or anything like that, just to protect yourself. And I tell them all when they come through the program, you have to be the one in charge of your own safety, because a lot of companies, they're going to cut corners or they don't know. I walked into a shop one time and like everybody in this shop is welding stainless. These guys over here, they're TIG welding it. These guys over here, they're MIG welding it. And I was like, man, you guys don't wear respirators? And the guy's like, well, why? And I was like, you realize like they're just releasing volumes of hexavalent chromium into the air. And I sent them the whole write-up from OSHA and everything. And, they implemented a respiratory program. I don't want the employees to know that, because they'd be probably pissed off at me because now they got to wear respirators. But, it's for their health. Anything that you do within welding it can be considered dangerous. So you have to protect yourself with the right PPE. I get people all the time. They're like, hey, I want to get my kid in welding because I heard it's a great career. But, what about the safety factors? I said, well, if you learn the right way to protect yourself, you shouldn't have to worry about it. Wear a respirator whenever you're working with this type of stuff. Make sure you got your safety glasses on. Wear the appropriate gloves for the task at hand. Put a welding jacket on. I talked to one of the guys that did a lot of weld testing for CE testing and stuff, and he had just scars all over his arm like he put it in a wood chipper and got it back just in time. And I said, hey, man, can I ask you what you did to your arm? And he goes, yeah, when I was young in this industry and welding, I never wore a welding jacket. I didn't wear welding sleeves. I just, I was one of the cool guys that, it's a welder's tan. And now he's just getting big segments of melanoma skin cancer cut out of his arm every 6 months, and they're sewing it back up. And I had melanoma on my back, and when they pulled that thing off, it was, just the patch of it was probably 5 inches wide and about 5 inches long and 3 inches wide. And they pulled that off for just a tiny little mole, but it was stage 4 melanoma, so they get aggressive with it when they got to cut that stuff out. So protect yourself, exactly. Take care of yourself. You're responsible for your own safety at the end of the day.
Well, I'm 62 here in a few days. And so, I guess I made it through okay. Got all my fingers, all my toes.
Right. Still working. No plans on retirement.
Well, still working, still can breathe. Still feel kind of healthy. Mason Winters come and help me when I had a little bit of a back problem. And he was sent to me. I don't know who sent him to me. I think Komlos sent him to me. But I think these kids nowadays, like with Chandler Vincent and Mason Winters here in Utah, I think they're going to get to see some good work coming through. Mm-hmm. I know I'm working with some people right now that are with part of space launch, and they're concerned about titanium welding coming down the road. So, they're picking my brain on how to do certain things, but these guys are looking to make space launch into an industry kind of like the car industry. So if you can think how people can be looking at that, like how do we put in the infrastructure to be able to build parts like this? Mm-hmm. So, I know you talked to Chandler about his business, but I think them guys are just so good that work's going to find them.
Yeah. Just
like me, I don't advertise. It finds me through other people, and which is good because everybody usually pays. If you come by, if you're affiliated with people, mm-hmm. you don't want to have one of your buddies, not pay one of your customers or something like that. So it's worked out really good with me. But with Mason, I'm going to try to get him groomed in to take over for me after I'm done for the Moxie. You know what I'm talking about, the Moxie, right?
With the Mars rover?
Yes. From what I've heard is right now I'm doing some stuff that's going to Colorado School of Mines to do some testing for something they're going to do with the moon and the Moxie. But that Moxie, it's going to change how space goes out there. It's almost like a first aid kit, survival kit type thing that'll go out there that, it's got fuel or some of your living things. So it's not going to stop. It's one of them things. I think it's going to be part of space. And if I can get Mason groomed in there to be able to take right off, they shouldn't even have a burp in the mm-hmm. project. And then I know Chandler's right behind there too, another person. So that's what I can at least say, that if I can't do the job, at least I know some people we can hand it to and put a good stab at it.
Yeah.
Mason's got us beat. He's got the welding engineer. And, I pushed him. He didn't want to go to school, and hopefully I pushed him a little bit. But finally, when he decided to go to school, I think he realizes that now that he can stamp his drawings, how much more money he'll make.
Yeah.
Rather than me, where I had to have all engineers do it, but I didn't have the responsibility of it. I didn't have to pick up the insurance for it. But I've worked under engineers all my life, so he doesn't have to do that.
Yeah, I had a student in my office last week. He was a former graduate, and he's talking about, he's like, I don't know, man, I'm thinking about going to get my welding engineering degree. And I'm like, do it. If you think if we're short welders, we're short welding engineers, and then somebody that has the ability to actually perform the welds and then going in there and getting your welding engineering degree, you have a much better understanding and background, so when they start talking about the different metallurgical structures and joint configurations, you're going to understand that. Now you're just going to apply the math to it and the statics and the strengths of materials and all that stuff and go for it, man. And there's so many companies out there right now that'll give you scholarships to where you can practically get that degree for free. It's just time and effort.
Yeah, well, I don't know about the free part of it. Everybody complains about what school costs, but
but there's companies that'll give you scholarships.
They'll make it back.
Yeah. Oh, hand over fist. That's definitely a good industry to get into. I'm not smart enough to do it, or I ain't got the time.
They do need to make some kind of program to check welding engineers' welding symbols. Man, yes. I can't find an engineer anymore that knows anything about it.
That's 100% true. I've gotten some weld symbols on there. It's like, how you want me to put this groove weld here on this T-joint? You just like clip arting this thing together or what, Chief? Yeah, they put some interesting stuff on prints every once in a while, and we do that with the students. We started doing project-based learning. So we'll put in wrong weld sizes and wrong weld symbols and see if they catch it. Or we'll omit certain things on the print, so they have to come and ask for us and say, okay, this is what's called an RFI. So you're going to submit that request for information to your shop supervisor. They're going to run it up the chain to the engineer to get you the answers for it. So we build pitfalls into the prints now just to get them used to working in industry, because it's never 100% correct. It's never right.
Yep. Yeah, and like we say, these kids are so used to using programs to build everything that I don't know if they even have a program out there for the weld symbols.
I think that's the hardest part of most drawings. Every time I talk to somebody, is like that's the hardest part of running that software, is finding out how to put in the weld symbols and the text and all that stuff, because they can draw everything up and dimension it, but the welding symbols is always where a lot of those programs fail.
Yeah.
And as far as intuitiveness and stuff like that.
Yeah, and you know how a welder is. You break him down for a minute, he's going to take 20.
Yeah. We used to do. I did a couple of structures where we had to go out there and do rehabs and repairs, and I bring the engineer out and be like, "Hey, man, how do you want to fix this?" And they'd be like, "Well, I don't know. I've never run into a situation like this." And I said, "Well, I'll tell you how I would do it." And I, kind of explained my thought process, my method. And he's like, "Well, let me run back to the office. I'll run the calculations. You send me a picture of what you got here, and I'll write it up and stamp it if everything checks out." Okay, cool. And that's exactly what we would do.
Yeah.
So it works out. And they just, you gotta be able to work with them. And for the longest time, there's been like this rub between engineers and the welders. And it's like, if you guys just work together on these things, you're going to make that engineer much better for the next job. And he's going to make you better, because you're going to have an understanding of what's going through his mind when they put this stuff together. Because they don't just open up a book and be like, yeah, this looks like it'll work, and throw it at you. There's some thought put into it. Calculations are ran. Learn both sides of it a little bit.
What I find out a lot of times is them engineers will bring me the last part I'm going to put on. They'll bring it to me first. And it's always because it's got the most critical thing there. Mm-hmm. It's like, well, this is the last thing you want to put on. If you want all these measurements to jive, it's the last thing to go on. And it's kind of funny to watch them mature. Over time, like the first one is backwards and the second one's halfway back. And then the third time, oh, well, we're bringing these down now, but here's the other parts. Mm-hmm. They finally starting to catch on now. They can kind of see it. So that's what I've really enjoyed about the Mars work, is watching some of these younger engineers mature to who they are now.
Yeah.
I'm proud of them.
I did a lot of work. I did a lot of work off of sets of prints for this one specific company here in Orlando. And I was talking to the engineer, and I was like, man, your prints are like always spot on. Everything's detailed. I don't have to do any RFIs. It's spot on. Like, how do you figure, how do you manage this? Like, because I've done several jobs for this guy. And he says, we take all of our engineers as soon as they come out of school, and they don't touch the drafting software. We put them in the field for 5 years. And if they can make it through that, then they can come in here and they can start detailing things out. And I was like, man, that's a good way to do it. They got to go out and get that experience out in the field, right there, right there with the tradesmen. And then they can see, exactly how these things go together and why you can't put welds in specific spots. Or if you do, it's got to be welded out first, not last.
A lot more engineers now, though, mm-hmm. Different types. A lot of the engineers I see are chemical, electrical. I tease the electrical ones all the time, because what's an electrician always trying to do? Keep the electricity in the line, correct? Mm-hmm. What does a welder do? We let it out. It's like, so, we're their enemy all the time.
Yeah. Awesome. Tony, I really appreciate your time. I know you got a lot of things going on right now, so I will let you to it, but I just want to say thank you for coming on the podcast. It's been a pleasure talking to you. Maybe I can get you back on at a later date, or maybe we can do one with you and Bill and have you guys come on.
That too, and you ought to check into that Jeff Taniguchi.
I'm gonna do that.
He's taught a lot of kids.
Okay.
And man, how can you teach these kids and still have a sanity? But I run into kids over here in Salt Lake, and we're from Vernal, and I said, well, do you know Jeff Taniguchi? Mr. T? Everybody knows him. So
okay.
I think as far as a teacher, because you're into teaching, maybe pick his brain on how to keep these kids interested.
Okay.
Because even Chandler will talk him up. I know Chandler goes in welding specs for him over there, for the competitions and stuff. But Gooch has been affiliated with your Skills USA for years. So
okay.
Pick his brain on how you keep these kids, coming to class and not spit and chew on the ground.
Oh yeah, I don't stand for that.
Yeah. Well, okay, Jason, good talking to you too.
You as well, sir. All right, ladies and gentlemen, thanks once again for tuning in. I hope you all have a safe and productive week. It's getting hot out there, so make sure you're drinking plenty of fluids. Be sure to tune in every Monday for more episodes of the show. And until next time, make every weld better than your last.